Now I know this looks like a Euclid proof, and indeed it is a proof, but it is not a Euclid proof, okay? And you're going to find this in calculus. We're going to prove a lot of things in calculus, but they're not going to be directly related to Euclid. But by getting used to Euclid's proofs, you can better understand these kind of proofs. And we are actually going to use Euclid's proofs to prove this, okay? So when it comes to Descartes, Fermat, Newton, that's Isaac Newton, you're going to find a lot of proofs in their work, but they're not exactly related to this, because they didn't live at the same time as Euclid did. Even Ptolemy did not live at the same time as Euclid. Okay? So, even though we are going to be presenting proofs, not all of them can be attributed to Euclid. In this case, what we're going to prove is that if you have parallel lines, then what we can successfully prove is that the slopes of these lines is equal. Now, how do we do that? Well, first of all, you have to comprehend the angle of inclination. What is the angle of inclination? Okay, this is what is called the horizontal axis. If you remember from Descartes' work, you have the Cartesian coordinate system. You have the horizontal axis. Now, why is it called the horizontal axis? Well, this is directly related to the horizon you see every morning when the sun rises. Okay? That's why they call it the horizontal axis. Okay? They also have the vertical axis. This is where you get the word vertigo. Okay? That's vertigo and vertical come from the same place. And that would be the up and down axis. Okay? So, this is the horizontal axis. And what we have done is we have drawn 4 lines. You can see lines A, B, C, and D. But the one thing that's in common with all 4 of these lines is that angle M. Now, angle M has the same number of degrees here as it does here, as it does here, and as it does here. Okay? Now, the first thing we have to do is we have to prove that if these lines are parallel, then their slopes will be equal. Okay? Now, we already know that the angle of inclination in these parallel lines, all 4 of them, okay, we know those angles of inclination are equal. How do we know this? Because we have to go back to Euclid Book 1, proposition number 28. They said, wait a minute. We're going to go back to Euclid Book 1, proposition number 28? You betcha. And if you draw this diagram for yourself, and I hope you do, and you rotate it a little bit, you will see the proof of Euclid Book 1, proposition number 28. You'll see it for yourself. So, draw this picture out, rotate it a little bit, and as soon as you do, you will see Euclid Book 1, proposition number 28. And therefore, we can say that the angles of inclination in these 4 lines is equal. Okay? Now, if 2 angles are equal, their tangent values are also equal. Now, do you remember how you derive the tangent value of an angle? Okay? What you do is you have the adjacent over the opposite. Okay? So what you do is you measure the adjacent side of a triangle and the opposite side of a triangle, and when you did that, that ratio would be the tangent value of this. And if 2 angles are exactly the same size, then their tangent values are going to be exactly the same. That's just a fact. Okay? So, if the angles are equal and their tangent values are also equal, well, we already know that the tangent values produce the slope of lines. Okay? So if you're looking for the slope of a line, all you have to do is find the tangent value and you found the slope. Therefore, we have now successfully proved that if two lines are parallel, their slopes are going to be equal. Now the only question is, if two lines have equal slopes, can we actually prove that those lines are parallel? Well, that gets a little more complicated, and we're going to have to do that in a different video. But now we can say that if you have two angles like this, these are angles of inclination, if your angles of inclination are equal, okay, and you have parallel lines, which makes those angles of inclination equal, then you can say their tangent values are equal, therefore the slopes are equal. And that's where we get that. Alright, so now we have a proof. It is a calculus proof, but it is not a Euclid proof. Alright, I will tell you more in a future video. Stay tuned.